Welcome back to our series on the RPO sequences. Today I'm going to be covering the RBar approach. So taking a look at where this can be found, it's going to be the RPO specialized RBar and VBar subfolder here. And we're going to be taking a look once again at the RBar approach, which is located right here. So this, as opposed to an RBar hop, gives you a little bit more flexibility and control. So first off, as the name suggests, I am going to be needing to starting off on my RBar, and it's going to take me to another location on my RBar. So that's what this RBar approach is, but it gives you some more knobs to turn. So let's taking a quick look at our initial state. I am starting off at 100 meters, my RPO, above my target satellite with a radial offset. And then we come down to the RPO approach, and we can specify the final duration over here, the 50 meters. So we're going to want to go from this location to about this location right here. And then we specify a transfer time. So unlike the RBar hop, which is dictated by pretty much natural motion after you enter it, this RBar approach is actually going to try to stay along the RBar. So if you want to maintain some sort of constant geometry or viewing angle of your target, so if you want to basically come down directly towards your target here, you can do actually a series of small burns instead of just one. You can do a series of small burns to keep you along this RBar. So that's what the sequence is going to be doing. So you specify the transfer time in order to get there. We're also going to specify the max in-track error. So this will be dictated by the, this will change the number of burns we need to do. So we might need to do a bunch of really small burns to keep us really near this in-track. Or if we have more error, maybe we'll come off a little more and maybe do a little bit fewer burns. You also have control over the in-track rate error. And for this engine model, it's going to be taking the default as prox op engine. You can use impulsive or finite. We're just going to stick to impulsive here, as well as who am I? It's going to be this RPO satellite. And this sequence needs to be named appropriately, needs to match whatever is in your MCS. So let's take a quick look. I'm going to go ahead and run this. It'll take a few iterations to converge, and then we'll take a look. It's going to perform a maneuver to kick us off, and it's going to be an initial radial rate maneuver in order to get us like moving downward. Then it's going to be doing a series of small in-track burns. So we're going to be doing a series of small in-track burns in order to get down to this target location. And then at the end, we're going to want to, once we hit the RBar final location, we're going to want to match our relative velocities. So if I go back up and rerun this, maybe I don't want my in-track error of 10, maybe I only want that to be 2. Let's run this. It'll take a little bit longer to converge. And I think the number of hops changed here as well. We could go back and check our maneuver summary, but it did change our sequence over here. And then you can see we're actually much closer to that RBar, and we only have a 2-meter offset. So it's going to be performing a series of small maneuvers. So if we go take a quick look at the maneuver summary over here. Yep. It performs that initial radial rate burn over there. Then it's going to be performing, in this case, it really only did one, smaller impulsive burns to keep us along that RBar. If I had maybe traveled further, it might require more in-track burns. And that's all actually handled by the auto sequences. So if I actually take a quick look, we're not going to go into too much detail here, but these conditions will get turned on and turned off based off of your approach up here. And this will require some of the subsequences that also come with the RPO sequences. So if I go take a look, there's this RPO Support sequences folder. And some of these sequences get called, these in-track and these radial burns get called by some of these, by this RPO approach right here. These in-track ones get called by this RPO approach. So it does require other sequences. I just wanted to make you aware of that. We don't need to go into too many details there, but these sequences that get run are other sequences that kicked off once it exceeds the maximum error. And then one last thing to note, besides starting and stopping on the RPO, even though it stops you on the RBar, it's not going to be a stable location, so you'll need to either maintain it or do something once you're there. And then lastly, you don't want to cross through your target. So if I'm above in the beginning, it won't allow you to go through my target and hit negative because you don't want to actually hit the target satellite. And same is true if you're in negative, it won't allow you to go up to the positive. Okay, so that's going to be it for the RPO approach.